The use of generative AI tools is driven by prompting. A prompt is a piece of text describing a query to LLMs. The crucial point of these technologies is that we cannot open and change directly how they work, but we can use them almost as black boxes. The first and the simplest degree of freedom we can use to control LLMs is prompting. Prompt engineering is the art and science of crafting inputs to get the best results from a large language model like GPT. To clarify better, large language models do not think, but they react to how you phrase the prompt, and the same model can give very different answers depending on how you ask. Thus, finding the best prompt for a problem becomes a central task in practice. You can imagine a practical example in the case of legal contracts. A naive prompt such as "What does this contract clause mean?" will produce a very general answer without detail. A more accurate prompt such as "You are a corporate lawyer, interpret the following contract clause focusing on risk for the vendor" will produce a very detailed answer focusing on the specific issues remarked in the prompt. Another issue that is crucial is that the capabilities of the LLMs are limited by the knowledge base used for their training. In many contexts, you'll like to ask the LLM questions requiring some reasoning on your data, but it is not possible without providing the LLMs with your data. Two approaches can be followed when it is necessary to combine own data with LLMs. The first is called fine-tuning, while the second, RAG. Fine-tuning is when you take a pre-trained AI model and train it further on your own data to specialize it for a particular task. General models might not speak domain-specific language and need to be specialized in specific application domains. A fine-tuned model understands your context better and delivers more relevant task-specific answers, but it requires time, data, and computation. RAG combines two techniques, a language model and a retrieval system. Before answering, the AI fetches real-world documents using the retrieval system and uses these documents together with the language model to generate a response. No retraining of the model is performed. To clarify better, fine-tuning changes the model itself. It's best when you need to deep expertise baked in the model. RAG doesn't change the model. Instead, it augments it with external documents on the fly. Think of fine-tuning as changing the brain. RAG is like giving the brain access to a library. Finally, we mentioned the paradigm of neurosymbolic AI, whereby tools such as LLMs are combined with other forms of AI. The motivation example is rather simple. LLMs work very well with text and images, thanks to the large amount of data used to train them. On the other side, they do not embed algorithms to reason or calculate. For instance, if we want to obtain an accurate weather forecast, an LLM can provide an answer, but that answer will not be accurate as it cannot do any mathematical calculations or simulations. In the neurosymbolic paradigm, an LLM is used to interact with humans, and its output is the input to a specialized algorithm doing a task. In the example of weather forecasting, the human could ask for some specific kind of forecast, specifying particular constraints and parameters. And the LLM will formulate a forecast problem in a mathematical fashion that will be provided to a simulator. In this way, we obtain a flexible tool capable of guaranteeing highly robust outcomes.